Algebra 1 Lesson 68, we are looking at some probabilities again, both mutually exclusive and inclusive events. Mutually exclusive events, like it says in the vocab, are two events that cannot both occur in the same experiment. Whereas inclusive events, these are ones that can occur at the same time. We have some overlap. Let's start with mutually exclusive. So we can have more than one event happening. Sometimes they can occur at the same time, sometimes they cannot. So here's an example. With a coin, we can flip a heads or a tails, but we can't flip them both at the same time. These are what we call mutually exclusive events or disjoint events. Another example would be like on a six-sided number cube, rolling a 2 or rolling a 3. They can't occur at the same time. This is how we find the probability of these mutually exclusive events. If A and B are mutually exclusive, then if I find the probability of A or B, I can just do the probability of A plus the probability of B. That or in our, the or in the formula often refers to the addition sign in probability. So, with my example of if I want the probability of a 2 or getting a 3, then I would say, what's the probability of getting a 2 plus probability of getting the 3? And I could say, well, that's 1/6 plus 1/6. And so we would say, oh, that's 2/6 or 1/3. Let's look at this bigger example. Now we're rolling 2 dice. And I want to find the probability of rolling either a sum of 6 or a sum of 11. Well, these can't occur together. We can't have, when we roll 2 dice, getting a sum of 6 and a sum of 11 at the same time. That's not possible. So we need to figure out the probability of each one individually. So what I need to do is probability of the sum of 6 or the sum of 11, and then I'll split them out. That means that I want the probability of the sum of 6 plus the probability of the sum of 11. Well, we can make a big chart and show all of the different sums here. So 1 and 1 gets 2, 2 and 1 gets 3, 3 and 1 gets 4, all the way down. So let me fill this in really quick. Okay, so let's look at, we have 36 possibilities. So in each of these probabilities, they're going to be out of 36. And let's look at all of the different times that we get a sum of 6. Well, when I look at this, I'm going to circle all of the sums of 6s. Okay, all of those green ones. And it looks like I have 5 out of 36 that give me a sum of 6. And then for my 11s, okay, I have 2 of them. 2 out of 36. And in order to find this mutually exclusive event, I'm going to add them together. So that I see, well, I could have reduced 2 over 36, but it's actually good I didn't, because I can add these up with those common denominators and find that the probability is 7 out of 36. Okay, let's try another one. What's the probability of either rolling a sum of 5 or a sum of 12 using the 2 dice? So sum of 5 or sum of 12. So let's go back to this and say, if I am looking for a sum of 5, I'll circle them in pink. Now we have 1, 2, let's see if I can get it to do pink now, 2, 3, and 4. So there's 4 5s up there. So we would say we have a 4 out of 36 chance of getting a 5, a sum of 5, and we have a 1 out of 36 with my 12, and so altogether I have 5 out of 36 for my probability of getting a sum of 5 or a sum of 11. Okay, so these are mutually exclusive events. They can't occur together. So let's look at a couple other examples. Okay, but now let's see some inclusive ones. And these are also called joint events. But basically, when we do the formula, it's going to start out very similar. The probability of A or B is equal to the probability of A plus the probability of B. But since they're inclusive, there is some overlap. And we need to get rid of that extra that we have. So we are going to subtract the probability of A and B. Basically, when we do this, an example of this is, let's say we are looking at a number die, and I want the probability of getting a prime number. Okay, and we say, okay, well that's out of my 1, 2, 3, 4, 5, and 6 possibilities, 2, 3, and 5, those are our prime numbers. So we have 3 out of 6. And maybe I also want to know what's the probability of getting a prime number or a multiple of, let's say, 2. Okay, so out of my 6, I would say, well, my multiples of 2 are 2, 4, and 6, so I have another 3 out of 6. Well, if we left it as this, we would say it is guaranteed 1 out of 1, okay, 6 out of 6, that we will always get a prime number or a multiple of 2, which is not true, because if you think about it, we have most of them covered, but this 1 right here isn't a prime or a multiple of 2. So how is it guaranteed? Well, the thing is, these are actually inclusive events because we can see that 2 has been covered in both of them. It is a prime number and a multiple of 2. So we need to subtract that probability so that we can fully see, oh, 5 out of 6 is my probability of getting a prime number or a multiple of 2. Because that overlap, that 2, got counted twice. It got counted with the primes, got counted with the multiple of 2. But we can't do that twice because it's really just one number. We have to subtract one of those times so that we're only counting it once. So let's try this with another example. If you're rolling a die twice, what's the probability of rolling at least one odd number or a sum of 8 using 2 number cubes? So, is it possible for both events to occur together? Yes, this is an inclusive event. Okay, so let's look at those odd numbers that we could get. And you can use a table like we did back at the beginning, but these are all of the different possibilities with an odd number included. There's 27 of them out of 36. Now let's think about how do we get a sum of 8? Well, that comes by doing 2 out of 6, 3 out of 5, 4 out of 4, 5 out of 3, 6 and 2. And those are 5 possibilities out of 36. But if we look at these, 3 and 5, 5 and 3, well, those were in my last list as well. Those are ones that occur for both of them. They're both odd numbers and they are a sum of 8, which means that's my 2 out of 36 that I am going to subtract. So I'm going to take the probability of getting the odd number. That was 27 out of 36. I'm going to add to it the probability of getting an 8, which is 5 out of 36. And I'm going to subtract from it my probability of both happening at the same time, which is the 2 out of 36. Meaning I am going to get 30 out of 36, which can be reduced to 5 out of 6. So it is a 5 out of 6 probability that you get a sum of 8 or a odd number with your 2 number cubes. So let's try another one. You can see that work once more right there. What's the probability of rolling at least one even number or a sum of 10 using 2 number cubes? Well, when we work it out, getting an even number has the same probability as getting an odd number. So we still have that 27 out of 36. Okay, the sum of 10, if we go back to our table from up above, we see that 10s occur 3 times out of 36. So we're going to say that's 3 out of 36. And the question is, when do they occur at the same time? Well, 10 can be made up of our 6 and 4, We could have also done a 5 and a 5, or a 4 and a 6, meaning 2 of them overlap because these are even numbers and they add up to 10. So I need to subtract 2 out of 36 because they were counted twice already. So I want to even it out by subtracting 2 out of 36, which means my answer is 28 out of 36, which reduces to 7 out of 9. Okay? These are inclusive events and I need to take away what has been overlapped. Here's another example. Let's decide, though, if this is mutually exclusive or if this is inclusive. So Jill needs to randomly call 125 people so that she can conduct a short survey. So she is assuming that everyone who is employed is younger than 75. So if the total population is 510,000, the employed people are 291,000, and people 75 and older are 29,000. How many people can she expect to call who are either employed or are 75 or older? So the question is, are these mutually exclusive? We want to know, is the probability of getting someone that's employed or 75 plus, can those happen together? And we say, well, no, because we are assuming that everyone who is employed is younger than 75. So I just need to take the probability of employed people plus the probability of 75 plus. So those employed people, that's 291,000 out of 510,000. Took off a couple zeros. And I'm going to add 29 out of 510. Altogether, we get 320 out of 510, which reduces to 32 out of 51. Now that's a probability of getting a person that's either employed or 75 plus. How many people will she actually reach? Well, if she is doing 125 people, that means there's a 32 out of 51 chance that she will get those type of people of the 125. So I need to multiply 32 out of 51 times 125 to get my expected value. Okay, take the probability and the amount that's happening, and I multiply those, and it's something like between 78 and 79 people. It's a decimal. It's kind of a funny one. Okay, so mutually exclusive events. Here's another one. A town contains 5,890 people planning to vote for candidate A. 6,910 people plan to vote for candidate B, and 10,050 people plan to vote for candidate C. In a random gathering of 200 people, how many would you expect to vote for A or B? Well, they can't vote for both, so this is mutually exclusive. So I would say, okay, well, what's the probability of getting A? Well, that's 55890 over the total plus 6910 over the total, and then I would reduce. Once I have that probability, I will just multiply that by 200 to find how many people would vote for candidate A or B. Okay. All right, Natalia has 26 rock artists, 18 pop artists, 19 country, 10 alternative, and 7 crossover. The crossover artists are pop and country. If Natalia's music player randomly selects the next artist, what's the probability that the artist will be singing pop or country? So is this inclusive or exclusive? Well, since we have those crossover artists, we say that this is inclusive. So we need to do this pop plus country minus the pop and country. Now let's look at these probabilities because we say, okay, there's 80 people total on her iPod. There's 25 that are pop. That's coming from the 18 plus the 7. And then we do the country. That's going to be 19 plus 7. And then since we counted those pop and country artists twice, we're going to subtract 7 out of 80. So total we get 51 minus 7 over 80. So 44 out of 80. The probability reduced is 11/20. And here's one last question that you can work out for yourself, just with a bag of marbles. There's some multicolored in there, so it kind of gives you a hint that this probably isn't mutually exclusive. There's going to be some overlap, so you can try this one out. Well, I hope this is helpful for your homework and for studying.